Welcome to the video for Lesson 7 of the Turn the Lights On curriculum. As the title suggests, it is now time to finalize our first prototype of the electric power generating plant, which meets all the criteria and constraints. Students will continue working on their prototype from Lesson 6 to meet the criteria of cost. In this lesson, students will calculate the construction and operating costs. As with previous lessons, in this video, we will go step by step through the lesson. The details about the activities can be found in the activity video for Lesson 7. At the end of this lesson, students will be able to use ratio and rate reasoning to calculate the construction and operation cost of their electrical power generating system. Develop a model to compute the total construction and operation cost of their electrical power generating system, and evaluate how their system meets the criteria and constraints of the engineering problem. This lesson requires two 50-minute class periods, so let's get started with the introduction of the lesson. The main concept in this lesson is about the cost-benefit analysis. However, in addition to this analysis, students will also learn from the important skill of evidence-based reasoning. You can tell students that both these skills are not only important for us to successfully complete our engineering design project, but they are also skills that are useful in daily life. You can give them examples from everyday life where these things are used. For example, the decisions their parents make when they are in the grocery store. How much does a specific item cost? Does everyone at home enjoy it? Will there be enough for everyone at that price? Are there better alternatives for similar or lesser prices? For evidence-based reasoning, you can use an example. Ask students, how can the teacher tell whether students have understood a topic or not? Use the students' answers to teach them how different pieces of evidence, such as responses to questions, test scores, attentiveness in class, homework, or etc., can be used to judge whether or not students have understood a topic. You can also use other examples to emphasize how we conduct cost-benefit analysis and evidence-based reasoning in our everyday lives and the importance of mastering these skills. But first, let us revisit our engineering design problem. Remind students that we addressed one of the constraints about environmental impacts in Lesson 6. Now let's try to see if our design meets the criterion of cost. Remind the students that the total construction cost should be less than $510 million, and the total operating cost per year should be less than $20 million. Use the engineering design process poster and students' engineering design process sliders to help students identify what they have done so far and what step they are currently on. This phase of the process is an excellent opportunity to drive home the nonlinear nature of the engineering design process. We will try our solution by considering the criteria, constraints, and trade-offs to come up with a prototype that meets all our requirements. We will also be testing whether the solution we propose meets the criteria, using appropriate evidence to support our reasoning. Engage students in a discussion about where the sliders should go in this part of the design process. Make sure that you emphasize that there are no clear and distinct boundaries between the phases, and that there's also no single correct answer. The amount of time that engineers spend in the try and test phases and the number of iterations they go through varies depending on the problem that they are working on. Cost-benefit analysis is an aspect of engineering that allows for a comparison of different systems. This also establishes a baseline cost of a system proposal for a customer to refer to as the design is being implemented. The first prototype allows engineers to see their designs built and measure them for cost and operation. If adjustments or updates are made, the prototype allows for testing and evaluation of these choices. You can pause here to watch the video given in the curriculum, which goes into the details of the cost-benefit analysis. Doing the cost analysis is more than a mathematics activity. By doing it, students work on important cognitive skills for other disciplines and their daily life. Remind students of the examples the class discussed in the introduction of the lesson. Then ask students how they think such skills can be used in their schoolwork. For example, in this lesson, students will look at the electrical energy output and costs for different types of power generation units. To compare the plants, students will have to use rate and proportional reasoning to analyze how much costs change per unit of energy produced as they choose among the power generating plants. This skill is particularly important in other areas, such as chemistry, where students need to understand how the changes in chemical reactions are proportional to the reaction stoichiometry. We encourage you to take this opportunity to help students develop this mathematical way of thinking. After giving these examples, ask students to think deeply about costs and benefits. Encourage them to go beyond the obvious, surface level factors and think about hidden costs or long-term benefits. Also ask students questions to encourage them to investigate relationships between the variables and the related costs and benefits. For example, what is the variable that most impacts the construction costs? How could you reduce their operating cost? After conducting the cost-benefit analysis, students use it in combination with their STEM knowledge to make decisions about which prototype of their design is acceptable for moving towards the decision phase of the engineering design process. Remind students that supporting their claims with evidence is not only important for them to defend their designs and analysis, but also useful in convincing the client why their design is the optimal solution and meets all the criteria and constraints. You can also spend some time discovering real-life and relatable examples of evidence-based reasoning. For example, you can ask them to think about how sometimes ice cream shops will give free tasting samples of new flavors. The purpose of this is to collect data about which flavors are popular with customers, analyze these data, and then use it as evidence to make a decision about which flavors or designs should be launched for maximizing profit, which also represents meeting the criteria and constraints. Then ask students to think about the different pieces of evidence they have collected through the previous lessons and how that evidence can be presented cohesively to defend their designs to the client. As we move into the activities, in this lesson, we will focus more on math and reasoning skills rather than hands-on activities. In the first part, the students will work with the cost-benefit analysis, and in the second, the evidence-based reasoning. As with Lesson 5, this activity also involves some math calculations. Here, the students will use basic math to calculate the cost in their designs. To calculate the costs, have students set up their prototype first, and then populate the table given in Worksheet 7A. Details about this activity are given in the activity video for Lesson 7. You can pause here or watch it later. This activity may be demanding for students with a limited math background. Depending on your own objective goal and time, you can ask the students to complete the analysis cost by hand using the Worksheet 7A. Or you can share the Excel file called Cost Analysis, where the students only need to introduce the number of employed units for each generating plant. The explanation in the activity video is based on the worksheet, but the steps can be adapted to use the Excel file. After the calculation, tell students that we are now going to see how the cost-benefit analysis can be used for convincing the client that our design meets the requirements outlined in the problem statement. The information in this slide is also covered in Part 2 of the activity video for Lesson 7. You will find the link below this video. You can pause now and go and watch it, or watch it after this video. You can tell students that this is the final prototype of the electrical power generating system. We are going to summarize all the information for our client in the evidence-based reasoning worksheet 7B. Make sure that students include information about the land occupation, power production, environmental impact, and cost analysis of their power system in the data evidence section. If time permits, you can also encourage students to think about factors where their design meets the criteria and constraints and present evidence for those claims. At the end of the activities, take pictures of students' final prototype and Excel files, or save the files in a flash drive. The students will need the picture and the Worksheet 7A or Excel file and 7B for the next lesson. Use the evidence-based reasoning rubric to assess the students' performance of Worksheet 7B and their overall learning of the lesson objectives. Review with the full class what they did in this lesson. Ask, can you tell me how we solve our engineering problem? Encourage students to be specific about learning activities and their purpose. You can also ask, what concepts are still confusing for you? Is it a final solution, or could you improve your design? What did you do well, and what did you need to improve about teamwork? Engineers usually have to redesign their solutions to improve them or address new criteria or constraints of the problem. We will work on that in our next lesson. Finally, take some time to plan for how you will implement Lesson 7. For example, you can think of ways in which you can adopt team learning pedagogies so that students can help each other in the math-based part of the activities. Take notes in your curriculum document about things you want to remember, and perhaps add information about the timestamps from this video that may help you later when you want to review. When you are ready, proceed to the Lesson 8 video.